Bismillah Rahman Rahim. Assalamu alaikum. This is Faryal Javed, roll number 21TE07 from Telecommunication Engineering Department, UT Texila. So today I am going to solve lab manual in 11 of digital signal processing, that is analysis of frequency versus Z-plane. So in this lab, we basically aim to analyze a relationship between frequency domain and a Z-plane in digital signal processing. By representing a signal in the Z-plane, we gain an insight into their behavior in discrete time system. This analysis helps in understanding how a frequency content in the continuous time domain translates to the complex frequency in a discrete time system. Moving towards task 1 of today's lab, explain the graph output in terms of frequency versus z-plane, poles and zeros, and here they given us the code to it, and you just need to determine that if it's stable or not. So in this graph, we basically plots the number of zeros and poles. As we can see that there is a zero at zero point 0.5 and no pole. In frequency response plot is generated by the frequency z. And moving towards the observation of this frequency representation plot, as we can see that it gradually decreases as frequency responses increases, typically shows that it's a low pass filter. In the z-plane plot generated by a z is equals to zero point 0.5 indicated that the cutoff frequency of a filter, and there is no pole suggestion that the filter is stable. Overall, these graphs illustrate how the presence of the poles and zeros in the z-plane related to the frequency representation of the filter, providing insight into its behavior in a frequency domain. Moving towards the next task of today's lab, to again explain the graph output in terms of frequency versus z poles and zeros. Here is output to our graph. Basically, the transfer function represents a discrete time system with both poles and zeros. In frequency responses, we observe that a system magnitude and phase responses across frequencies. The z-plane plot illustrates the location of poles and zeros, which influence the system's stability and frequency characteristic. And here, as you can see, we have three zeros and one pole. The zero is represented by this zero, and a pole is represented by the X sign. And here we have the frequency response and a phase response. So the coefficients here determines the relative strength of a system poles and zeros, influencing its overall response to input. Moving towards task 3 of today's lab, that is again to explain the graph output in term of frequency versus z plane poles. So basically, a zeros represent a frequencies, as we can see that where a system has no response, while pole represent the frequencies that affect a system response. So the frequency response plot here is represented by this frequency z, and the z plane plot z visualize how the location of these poles and zeros affect the system's frequency response and stability. So here, as we can see that there are four poles and two zeros. Moving towards the fourth task of lab 2 is where we have a numerator 1 and a denominator 1 and 1 by 2. Here is the output to our task. Here we have a pole located as z is equals to minus zero point 0.5. In the frequency response plot generated by, we observe that a magnitude and a phase response of a filter. Here is the frequency response and a phase response of a filter. So this plot shows how a filter attenuate higher frequencies while passing a low frequencies. So z is equals to minus zero point 0.5. It basically indicates the cutoff frequency of a filter. Since there are no zeros over here, the filter does not introduce any additional resonance or a null here. This transfer function express shows the polynomial coefficient of the numerator and the denominator. Moving towards task 5, where we have numerator 1 0.2 minus 3 by 2. Talking about the stability of a system, in the stability of a system in the z plane depends on the location of its pole. If the poles are within the unit circle, that is, if z is less than 1, the system is stable. If the pole lies outside the unit circle, that is, if z is greater than 1, the system is said to be unstable. And Moving towards the frequency responses, the location of poles affect the frequency response of a system. Poles closer to a unit circle influence the system response at higher frequencies, while poles closer to the origin impact a low frequency responses. And then I have already talked about the resonance and damping, but a poles closer to a unit circle contribute to the resonance phenomenon, while a system amplifies certain frequencies. On the other hand, poles farther from a unit circle contribute to a damping, which reduce the amplitude of oscillations. Here is the task 6 of today's lab with a numerator and a denominator. The z-plane plot visualizes the location of poles and zeros in the complex plane. Zero is denoted here by the x mark, while pole is denoted by the zero mark. The arrangement of poles and zeros in the z-plane influences the system stability and frequency responses. By examining the position of the poles and zeros, we can infer the characteristics such as stability, frequency, selectivity, and the transient response of a system. Here we can see that the system is unstable because of the poles that are because of the zeros that are outer side of the unit circle. Moving towards the other task, explain the graph and the output. I have already discussed this task. Moving towards the other task, that is, yes, task 9, to explain the graph output in terms of frequency versus z-plane, poles and zeros. In this task 9, the transfer function represents a system with 1 0 and a 5 poles. As you can see here, that the z-plane plot shows the location of poles and zeros of a complex plane. The task 10 again shows to explain the graph. The transfer function basically here represent a system with 1 0 and 5 poles. The frequency response plot indicates the system behavior across different frequencies. The z-plane plot illustrates the position of the poles and zeros. Here we have the other task. Moving towards last task of today's lab, the transfer function represents a system with 1 0 and 4 poles. The frequency response plot shows how the system behaves at different frequencies. The z-plane plot indicates the location of the poles and zeros on the complex plane. So this is it for today's lab. Thank you so much. Allah Hafiz.